This lesson is over section 2.1, and this will be the first part of 2 on the notes for this, because the notes are about 4 pages long. So I'm going to divide this lesson into 2 videos. So be sure and get you a pencil so that you can write along on your own copy, and then we'll be able to understand the information that's here. I will say something about your notes. The things that I give you to fill in the blanks often on these first couple of sections are going to be questions on the homework, and they'll be in a drop-down menu. So make sure that you pay attention to the vocabulary that's being used, because it's also going to be part of the instructions a lot of time on how they expect your answers to look. An equation is a number sentence. It contains numbers, variables, operation symbols, and an equal sign. This is the critical thing. If something is called an equation, it's going to have an equal sign in it. And that means that you're going to get an answer for that problem, a simplified answer that's just like one number, whether it's a decimal, a whole number, a fractional, positive or negative, you're going to be getting an answer. The instructions, if the instructions say solve, then you're going to be working with an equation. So for now, we're going to just use some simple equations that only have one variable in them. Later on, we'll have 2 variables that we work with. Okay, the answer to any equation is called a solution. In general, if you're going to solve an equation and they're going to tell you solve for a variable, certain variable, then you're just going to have to undo what's already been done to that variable. It's just like when you have a problem in your home. If you have 2 kids that are fighting, you've got to separate them and undo them until you can figure out what really happened and caused the problem. So the solution is undoing what's there. You have to do this. You're going to have to isolate the variable. That means you're going to have to use mathematical properties to move numbers around so that the only thing left is x equals something, and that'll give you your answer, your solution. Now, this is the most important thing that you work with when you're talking about equations. Equations have to stay balanced. That's what that equal sign in there means. It's like a seesaw. So whatever you do on one side of the equation, you have to do the same thing on the other, okay? That keeps the balance in the problem. Whatever you do on one side, you have to do on the other. Doesn't matter what you're doing. If you divide something on one side, then you got to do the same thing on the other to keep it. You got to divide on the other to keep it balanced. Okay, so here's the equations that we're going to be working on. We're going to solve some one-step equations. That means you're only going to have to do one operation to get to the point where the problem is solved. So when you do your work on an equation, work down the page, not across the page. So as you work, the examples I show you is the way I expect to see your work when you turn it in for me. So the first ones we're going to be talking about adding and subtracting. Now, here's one of the things that you need to realize. You should always be able to know if you've got the right answer. Check it by plugging the number that you get back in where the variable was. So if my original problem says A, that means some number added to 11 is going to equal 15. Now, you should be able to do that in your head. But in the process of learning how to do math, I'm going to show you all the steps for it. So if I have to undo what's been done so that I get the A isolated, I just need to do the opposite of what this is. So instead of adding 11, I'm going to subtract 11 on both sides. So now I have 11, positive 11 and a negative 11. That means they're just going to cancel out to be a 0. So I just have an A left here. And on the right-hand side, I'd have 15 minus 11. 15 minus 11 would be 4. Now, you can also think of this as a positive 15 and a negative 11. This is in terms of integers of what we're dealing with. When we deal with positive and negative numbers, we call them integers. So our answer says we think the answer should be A equals 4. Okay, so check it by taking the 4 and plugging it back in. So if I say 4 plus 11, is that truly going to be 15? Yes, then you know your answer is right. And then this is your solution. So a lot of terminology that you have to remember here. Okay, on this problem, it's the same kind of problem, it's except the variable part is on the right. It does not matter. You want to get that x by itself, so the opposite of adding 5 would be to subtract 5. So I need to subtract 5, so the 5s would disappear, but whatever I do on the left, I have to do on the right, and whatever I do on the right, I have to do on the left. So it has to be done the same on both sides of the equal sign. The equal sign is your divider. Alright, I'm going to subtract 5 underneath both places. So a positive 5 and a negative 5, or 5 minus 5, will just be an x by itself. And 21 minus 5, well, you know what? I don't need to stick that in my calculator, because I know that that 1 is not going to be big enough to subtract a 5, so I'm going to have to borrow. So that 1 is going to become an 11. Then 11 minus 5 would be 6. And I would leave a 1 in place of the 2, so my answer is 16. Check it. Does 21 equal to 5 plus 16? So look at it. Look at it and see. If I add those together, am I going to get 21? Yes, I will. So I know that's the right answer. So 16 is my solution for this problem. Okay, this problem is very simple. If I want the answer to come out to be 0, what do I have to do with 14? Well, that means I have to take away everything that would have been there. So I'm going to subtract 14 and subtract 14. So now on the right hand side of the equal sign, I'm still going to get 0, so x is all I have left. But now I have a 0 and I'm taking away 14 from it. That means I'm going to be going into negative money. So if you have nothing and you try to spend $14 on a debit card, it's not going to let you spend it. You could spend it on a credit card, but that just means you're going to owe $14. So in this case, we have a negative 14 because we didn't have any money to start with and we tried to spend $14. Now if I go back and check it, does 0 equal to a negative 14 and a positive 14? So if I owe $14 and I pay it off, am I back at 0? Answer is yes. So this is correct, and my solution would be negative 14. On a problem like this on your homework, it's going to say leave your answer as an integer, and that word integer is spelled I-N-T-E-G-E-R. That just means a positive or negative whole number. So your answer can be positive or negative. Make sure you do your math right. But they want an answer to be an integer, or they say it could be a fraction in lowest terms or simplest terms, or sometimes they say it can be decimal, so you have to read your instructions. Alright, here I have a negative 25 plus x equals negative 28. So now I need to get this negative 25, so this is basically subtracting 25, so the opposite of that would be to add 25. So I'm going to add 25 here, I'm going to add 25 here. Now my 25s are going to cancel each other out, so I get x equals, now if I owe somebody $28 and I pay them $25, I still owe them some money. I would owe them $3. So I have a negative 3 as my answer. So this number says you're going to go on a number line. This would say I'm going to go out 28 spaces to the left. So negative 28. Then when I pay it off, I only pay back 25 of it. So that means I'm never going to reach back to the 0 yet. So I'm in the negative side, so my answer would be negative. Now when I check it, if I have a negative 25 plus another negative number, is that going to still be negative 28? Now this means I'm accumulating losses, or I lose $25 and I lose 3 more. I haven't all of a sudden gained positive money. I'm losing and losing. So my answer is still going to be negative, and I've just combined the two numbers together. So now I've lost a total of $28, and true, the numbers are right. So this would be your solution. Now, if we talk about problems that have fractions in them, I know one of the things is that when you see a problem that involves fractions, because fractions are a difficult topic to understand, first thing your idea is going to be is, I'm just not going to do it. Well, that doesn't work. We can't accomplish a lot of things in life if we just quit. So the thing we're going to do is learn how to work with fractions. Now, to solve a problem that has fractions in it, the easiest things to do would be first, find a common denominator. Find the lowest common denominator, LCD. So I'm looking for the smallest number that 5, 7, and 35 will all divide into. So the smallest number could be 35. The question is, does 5 divide into 35? Yes, it does. Does 7 divide into 35? Yes. And 35 divides into itself. So the LCD here would be 35. Now, I'm going to use it to help cancel out those fractions. So I'm going to multiply that on both sides. I'm going to put 35 here, and I'm going to put 35 right here. Now, when you multiply, the 35 and the 5 are going to reduce. 5 goes into 35 7 times, so I'm left with 7 to multiply here, so I'd have 7a. Cancel out what you can. 7 goes into 35 5 times. So I take the 5 that's left over and multiply it here. So times 7 on the A and times 5 on the 2. So that becomes plus 5 times 2, that'd be plus 10. And that's a times, not a decimal value there. Okay? Now on the other side, 35 and 35 will totally cancel each other out, and I'm left with a whole number 9. Now I got rid of the fractions. So this is going to be a skill that we need to maintain, and we need to learn how to use it over and over again. It's going to be something we do all throughout this course. This is one of the easier problems, so as we go on, we'll do more practice with this. Now simplify what's left. I need to get the 10 by itself. So I'm going to subtract the 10 and subtract the 10. So now this time when I bring this down, this one falls into my next category actually. 7a, and I have a positive 9 and a negative 10. So if I have positive money and then I lose more than I've got, that means I owe something. So here I'm going to have a negative 1. Now the second step to this problem means we don't have a by itself. So this is actually a two-step problem. It doesn't fit quite this category, but we're going to go on and do it. So now the 7 is being multiplied times a, so the opposite of multiply, I'm going to divide by 7 and divide by 7. Whatever I do on one side, I have to do on the other. So now 7 divided by 7 does not go away to 0. Any number divided by itself is equal to 1. So this problem then becomes 1 times a would equal to negative 1/7. But 1 times anything doesn't change the value, so your final answer is a equals negative 1/7. Now, in this situation, there's no reason to put that into a calculator because 1 does not divide evenly by 7. And all you're going to do is get this giant decimal value. So leave your answer as an improper fraction. There's no reason to do anything else to it. This is what I'm looking for as an answer, as an improper fraction. Okay, over here we've got some decimals. You're going to have a calculator that you can use. So you can multiply, you can use a calculator straight as it is, but we can work with some other things. The best thing for you to do right now, just out of pure simplicity, would be take your calculator and do the opposite. So this would be subtract 1.25, and this would be subtract 1.25. So you can go to your calculator and subtract it. The one thing to remember is that when you work with decimals, you need the same amount of decimals on either side. So if I have a negative 1.25, think about it in terms of money. I lost $1.25. Now I found 50 cents. So where do I stand with my money? Well, that means I still owe 75 cents. So your answer would be negative 0.75. So most of the time with decimals, I'll show you another way later how to work with that, but for right now, it's easy enough to use your calculator. Now, if the answer says it cannot be a decimal answer, if it only says integers, okay, if the answer choices are integers or fractions, okay, integers or fractions, that won't be an acceptable answer. They'll tell you it's wrong. So what we have to do is, this is 75 over 100, so it's negative 75 over 100. And that can be reduced because you can divide them both by 25. How many quarters in 75 cents? Well, that would be negative 3 because you got a negative sign. And in $1, how many quarters do we have? 4. So there's our answer. So if it has to be fractions, it would be negative 3/4. If you have decimals to start in it, that's fine to get decimal answers. You just have to follow the directions that you're given. All right, number 7 and number 8, there's going to be a couple of problems like on this, like for homework. It says, is y equal 3 a solution for this problem? Now, all I want you to do is the check step. Just check it first, okay? Check it. So plug the 3 in where the y is and see if it makes a true statement. So is negative 5 plus 3 going to equal to a positive 2? So if I've lost $5 and I only pay back 3, do I have money in my pocket? Well, the answer is no. Okay, so this is not true. This is no. So then you need to work it and find the right answer. So you're going to go over here and go negative 5 plus y equals 2. Do the opposite to get rid of it. So plus 5 plus 5. Now I have y equals 7. So there's going to be 2 steps to this problem. There are some like this on your homework. Don't work the problem first. Check it first. Okay? Check it first and then you'll get your answer. If this is true, then you don't have to work it. All right, is negative 3 a solution for negative 17 plus x equals negative 14? So check it first. Check it. That's the first thing. Negative 17 plus negative 3, does that equal negative 14? Well, if I lose $17 and then I lose 3 more, how much money have I lost? I've lost 20. So this would be negative 20, and this is negative 14, and no, that's not true. Okay? Not true. So then I'm going to go back in and I'm going to work it. So negative 17 plus x equals negative 14. Add 17 to both sides, and x would equal to positive 3. So the problem is the sign was wrong. That's what you're going to find out happens on most every problem that we work with in the assignments is sign mistakes. So you got to be very, very careful. The first test, that's going to be the biggest problem, is making sign mistakes on the work that you do. Okay, let's look at page 2. Now, here's a little bit of extra things that we need to do. When equations have several variable terms or numbers that are on each side of the equation, then you've got to first collect like terms. So we want to collect things together that are the same. That way we don't have so many parts to it. Sometimes we need to just make it a little bit simpler. So here I have 2 whole numbers right here. Instead of working with an 8 by itself and a 5 by itself, let's add those together and call this 13 plus x. On this side I can put the 9 and the 4 together, and then I just have equal 13. Now that problem, you should be able to know what the answer is going to be. If I start out with 13 and I'm going to add something to it and I end up with 13, I probably had to add nothing. That's what made it stay 13. But in the math process, you would subtract 13 on both sides, then you'd get x equals 0. And 0 is a perfectly good answer. Don't think because you come out with 0. You know, if somebody mails you a bill, and it says that you have 0, you owe 0, that's a really good bill to get. So it's okay to get 0 for an answer. All right, over here, I guess I need to, can you see the top there? Over here, we need to look for like terms. Okay, so I have a -11 and a -4 on this left-hand side of the equal sign. So I have two negative numbers. That means I lost $11 and I lost 4 more. So now I've lost $15. Okay, on the right-hand side, I have 3 numbers that I could combine together. So I have 17 minus 14, so that would be 3, plus 8 would be 11. So combine things together so that you don't have to work with a bunch of individual pieces. Then here, I need x by itself. So the opposite of negative 15 would be add 15. I want to cancel that out. So I'm going to add 15. Put that right there. Okay, my 15s are gone, so I get x equals, now I just add a positive 11 and a positive 15, going to be positive 26. And you can go back and check it, plug the 26 back in and see if it makes a true statement. And it should. So your solution here would be 26. So the thing to remember, if you have more than 2 terms, okay, the minimum here would be 2. I wouldn't want more than 2. So try to have only 2 terms or less on each side. So if there's more than 2 terms, there's going to be something that needs to be collected together. So combine your like terms before you start doing anything else. Now, all those problems involved adding and subtracting. Here we're going to talk about multiplying and dividing. So remember that multiplication and division are opposite operations. So if something's multiplied to the x, then you're going to undo it by dividing it, and vice versa. If something's been multiplied, if something's been divided, you're going to multiply it. So here I have 5 times x, so the opposite of multiply here would be divide. So simply divide by 5, divide by 5. And then x would equal negative 12. Now if you plug it back in, a positive 5 times a negative 12, is that going to come out to be negative 60? Well, I have one number that's negative and one number that's positive, so if the signs are different, I know that's going to be negative answer. And 5 times 12 is 60, so yes, I know that's right. So I have the right answer. Again, the biggest mistakes you're going to make are sign mistakes, so pay attention to the details of what you're working on. Alright, so here I have a negative 3 being multiplied times x, so I'm going to divide by negative 3, divide by negative 3. This time, they both have the same sign. So negative divided by negative, if the signs are the same, the answer will be positive. So x equals positive 8 this time. And then you can plug it in to check it. Negative 24, is that going to equal to a negative 3 times 8? 3 times 8 is 24, and there's one negative sign, so that would be negative, and that makes that be the same. Okay, here I have decimal values. Okay, plug them into your calculator. So I'm going to divide by 0.5 and divide by 0.5. Alright, so what are you going to get? Well, 0.15 divided by 0.5. Okay, in terms of division, this is what it would look like. Now, I move the decimal one place and I move this decimal one place. That's how division is about. So now my decimal comes between the 1 and the 5. So when I look at my answer, 5 does not go into 1, so that would be a 0. But 5 will go into 15, so it would be a 3. So my answer would be 0.3 or 0.3. Okay, use your calculator. Alright, here I'm multiplying by 1/4, but this is the same anytime you multiply by 1/2 or 1/3 or 1/4 or 1/5. Anytime you multiply by that, this expression is actually the same as having x over 4, because this would be 1 times x and 4 times 1 if I put 1 under the x. So the same as x over 4 equals negative 14. Now, x is being divided by 4. So the opposite of divide would be to multiply both sides by 4. And over here, I'm going to multiply it as 4 over 1 because the 4 would be a whole number, so you write it as a fraction. So now the 4's are just going to cancel off, and I get x. And over here, I have negative 14 times 4 would be negative 56. So anytime you have 1/4 of something or 1/4 times something, of means times, it's the same as just x divided by 4. Okay? All right, here. Now, here's the problem where we can use that rule that we used on the other one with the fractions. Look and find your common denominator. Okay? The number that 3 and 9 will both go into, the lowest number. Well, that would be 9. Okay? So my LCD here is going to be 9. So I'm going to multiply this side times 9 over 1, and I'm going to multiply this side times 9 over 1. Now reduce the denominator into the common denominator. So how many times will 3 go into 9? That's 3 times. So I'm going to multiply 3 times negative 2 is going to be negative 6y. Okay, 3 goes into 9 3 times. Multiply the 3 that's left over times what's here. So 3 times negative 2 will be negative 6. Now over here, the 9's will cancel all together. So I just have 8. Okay, now divide by negative 6. And I have a fractional value because negative 8 over negative 6 is an improper fraction, but it's not reduced. Don't stick it in your calculator. 6 is not going to go into 8 an even amount of times. Simply reduce it. They'll both divide by 2. So divide them both by 2 and my answer ends up being negative 4 over 3. You just need a negative sign somewhere on that answer. It doesn't matter where. Okay? On number 6, my denominator is a 9. That's the only number that's there. So it's kind of like this one that we did. What you're going to do is just multiply both sides by 9. The opposite of divide would be multiply. So on the right hand side, the 9's are going to cancel and I'll just get x. And on the left, I have 9 times negative 7, which would be negative 63. Okay? The opposite of dividing by 9 would be multiplying by 9. Whatever you do on one side, you do on the other. Okay, number 7 is going to be like number 5. We need a common denominator that both 5 and 10 go into. They'll both go into 10. So my common denominator here is 10. So I'm going to multiply the left side by 10 and the right side by 10. Reduce out what you can. So 5 goes into 10 2 times. So the 2 that's left over is going to get multiplied to the top. So 2x. 10 and 10 will cancel, so that equals negative 2. Then divide by 2, and x equals negative 1. So some simple problems that involve fractions. Follow these examples. There'll be some like this on your homework. Okay, this one's a little different. In terms of this, what number is being multiplied times x? There's not a number there, but there is a sign. So that really means that's a negative 1 in front of the x. So all we're going to do is divide both sides by negative 1. And now we have negative divided by negative, which makes me have a positive on the x, so a positive x. And negative 22 divided by negative 1. The signs are the same, so my answer will be positive. But 22 divided by 1 stays 22. So you don't want a negative x for your answer. You want the x to be positive. So if there's a negative on the x by itself, it doesn't have another number, then it's negative 1. Really, all you have to do is divide by negative 1. All that's going to do is change your signs. So that's a tool. We've used 2 tools here to help us with math. A common denominator got rid of fractions, and here a negative 1 got rid of a negative sign for us. So there's some things that we'll talk about that we use in math that I call math tools. Now these 2 problems are similar to the ones on the other page. They just give you a couple of these on the homework too. Check the solution. Is 3 a solution for this? Check it. Don't work it, check it first. So negative 9 times 3, is that going to be positive 27? No. Okay, so then solve it. Negative 9x equals 27. Divide by a negative. So what was the mistake? They left their sign off because it should be negative 3 for the answer. Okay? Alright, check it first, then solve it if it doesn't work out. You can probably see what the mistake would be. That's a big thing about working with math, is being able to understand the process and look at the numbers of what we're doing. Alright, check this one. Is negative 18 a solution to this? So now I'm going to put a negative 18 where the x is, but it already has a negative sign. So if I have positive 18 equals negative 18. Now, when you work with double negatives, the one outside, we read it to say the opposite, and this one we call negative. So this says the opposite of negative 18. Well, what's the opposite of negative 18? That would be positive 18. So 18 equals 18. Yes, this one's true. So your answer here simply would be yes. You don't have to do anything. Now, on your answer terms, in terms of answers for these problems, I prefer that your answer be in fractional form rather than a decimal form. Your answers on homework, you have to follow the directions. In algebra, teachers are going to prefer an improper fraction answer, especially if the answers don't reduce out to be a simplified. And I will say this, if the answer is 0.5 on your calculator, you can simply write it as 1/2. That's easy when I'm asking for a fractional answer. But if you get some strange decimal value and you don't recognize what the fraction would be, that creates a problem. So you're better off leaving it just as a simplified fraction in lowest terms. So if I get 7/2, 2 can't go into 7 evenly, just leave it that way. That's an acceptable answer. Don't change it. That is the improper fraction form, and that's what we're looking for. That's perfect. Now, here's a point that I want to make. The solution to equation is in a value that makes the equation be true. This allows you to check your answers, okay? All you have to do is plug them back into the original equation and then make sure that the numbers are the same on both sides of the equal sign. So check your work. You shouldn't have to even think on a test, are my answers correct or not? You should be able to just check them and then see if they come out to be right. Alright, now usually you're going to have more complicated equations to work with, so the second part of these videos is going to be the two-step equations. So I'm going to stop here on this one, and then we will have another video to get you the second half.